Hello, everybody, and welcome to episode 75, in which we're going to further explore the cluster API Cilium setup. We're going to play a little bit more with how can we instantiate clusters with Cilium or guest clusters with Cilium and that sort of stuff. So, welcome to episode 75. Welcome to the new year. It's Friday the 13th. I have zero expectations that we're going to be able to get all the way through this. Here on this beautiful Friday the 13th, we're going to give it a shot. We're going to at least learn some stuff together and have some fun. So let's get into it. All right. As usual, let's get started with some news. If you want to subscribe to this newsletter, the way that you can do it is by going to cilium.io/newsletter, and you'll be able to put your email address in here and click subscribe. If you want to see the previous versions of this newsletter, jump in. If you have something you want to share, you can just DM it to Bill or tag him in a Twitter post, or you can also submit it on Slack or in a forum. So if you have some really interesting stuff for happening with eBPF and you wanted to share that, that's one way to do that. One of the new blog posts that we have on Cilium.io is a user story talking about connecting 390 plus stores and 4.3 billion website visitors. It's a pretty incredible story. And this user story is coming from a company in the retail industry, talking about building a secure private cloud, talking about their native requirements. And then the effort actually included a migration from Calico to Cilium, and some of the benefits that they're getting from this and what we're actually working on for them. Definitely a pretty great user story. The news this week. This is the newsletter I was talking about, if you would like to subscribe. Oh, yeah, Tony checking in. How you doing, Tony? Good to see you. And if you're in the audience, just go ahead and say hello, and I'll throw you up on the screen. Say hello back. Be nice to know you're out there. So this week, on the technical side, we have pod traffic rate limiting with Cilium Bandwidth Manager. I believe there's actually going to be a lab soon. And remember that if you want to check out our labs, you can go to cilium.io/labs or is it isovela.com/labs. One of those two, and you'll be able to explore those labs. There's a great topic on eBPF and its capabilities. How you doing, Michael? Good to see you. Hello. And a great talk about eBPF, a new frontier for malware. Lots of great stuff happening in that space. Hey, Rangathan, good to see you. Or Raghunath, I'm sorry. Nice to meet you. Welcome. We have eBPF L4 package dropper, which is probably just using XTP to drop traffic, and then ground cover comic, a lightweight eBPF-based network tracing map visualized through Grafana to expose all of your Kubernetes production interdependencies. Pretty cool. And then the ecosystem, talking about the timeline of eBPF. That's interesting. Yeah, lots of good articles this week. Kubelift getting started, observing ingress and pod-to-pod traffic with Cilium Hubble. You don't see anything? You don't see any screen. Do y'all see the screen, or is it just me? Hey, audience, can you see the screen on the right and me kind of to the left of that screen? I hope you can. Oh, I see. You're coming possibly from something that isn't actually got the screen shared or something. I see. If you go to our YouTube channel, you'll be able to watch this live. Blank screen. Okay, well, here's what I'm going to do. I'm going to put a link into I'm going to put a link into the chat here so that you can use this to follow along if you'd like. So give me just 1 second. Oh, probably going to give me some weird links here. So copy video URL, close that, and I will put this into the chat. And then anybody who can't see us can follow that link, and it will take you to the YouTube live stream where you will be able to see the output. I'm actually not sure which destination you're coming from that is keeping it from working, but if you can follow that link, then you should be able to see it there. Hopefully that link works. All right, let's keep going. So when last we met, I was working a little bit with Cluster API, and we had explored the idea of using cluster resource sets to do the install of Cilium. And we ran into some challenges. Cluster resource sets is a functionality inside of the Cluster API project that allows us to have particular YAML manifests that are stored as kubeconfigs applied against the against your guest clusters. So when you create a cluster API management cluster, and then you create guest clusters off of that, cluster resource sets are a way that you can get manifests applied to those guest clusters. And the way that it works is actually pretty Kubernetes centric. How's it going? Welcome from Edinburgh. Good to see you. And Oyvind, good to see you. I'm actually and the way the cluster resource sets work is that you can create guest clusters, and then you can have those cluster resource sets apply against those guest clusters based on a label match. So if you had a bunch of clusters and you wanted to apply Cilium to them, then you could label those clusters Cilium true or whatever, and then the cluster resource set would apply to them. The challenge that we ran into is that it actually takes quite a bit of permissions to apply Cilium into a cluster, right? We need the ability, if you think about it, what's happening here is that I had created a container image that would deploy, that would use Helm to deploy Cilium into the guest cluster. Actually, maybe even been the Cilium installer that was doing the work. Regardless, for that work to complete, it needs to have a significant amount of permissions for it to actually do the installation itself, because Cilium requires access to writing and creating custom resource definitions. It requires access to make privileged daemon sets. It requires access to do lots of things like this to be able to do its job. And when the cluster resource set applied, it just gave it the permissions of a default service account. And that default service account clearly did not have any of those permissions to delegate to the Helm apply command. And so we ran into difficulty there. And I read a bit more about cluster resource definitions. If you want to read more about them, you can actually follow the link directly from the notes here. But let's go ahead and open up the Cluster API document. And we'll do a search for resource set. This takes us to the proposal, which talks about what the motivations are and those sorts of things. But the idea being that you could actually have a set of resources that were applied to your guest clusters, but the permissions are kind of up to you to define. In this example, they're installing Calico. There's also examples out there for how to install Cilium in this way, but they generally default to an administrative credential to do this work. And I kind of wanted to introduce a different way of thinking about this problem. And so I was thinking about it over the holiday break as we were thinking. I was thinking about how we could actually solve this problem. And I think I've come up with an interesting way to do it. And we're going to kind of dig into it today to see if what I'm thinking about is possible. But the idea that I had was, what if we figured out a way to use a cluster resource set to apply Flux, and then use Flux to do all of the instantiation. From there, we can install Cilium, we can install some sample applications, we can install all of that stuff without having to make any further changes, because we will already have Flux in place, and then we can kind of get pretty creative about how that works from there. So my goal in this series of episodes is to figure out how to do that. Now, what the resources that we have at our disposal so far, we know that we have the ability to generate clusters, and those clusters start without a CNI. We know that we have the ability to use cluster resource sets and apply simple manifests to those guest clusters. So we could do a Cilium install in that way. We also have the ability to, we also know a bit about Flux, and I'm also very curious about using Flux for its capability of installing and managing those manifests directly. And in that way, we could actually use like Flux v2 to bootstrap everything. Instead of just using Flux to install everything after the CNI, let's just use Flux to install the CNI as well. And in theory, we could even use Flux in a bootstrap way against the management cluster itself to instantiate the guest clusters and do all of those things. But I think that's probably going to be a bit further down the road. Our first goal here is to figure out if we can get Flux going, and then we're going to use Flux to install Cilium. Now, in the notes, I linked a couple of different things because I was trying to figure out basically, can Flux be installed without a CNI? And I found that I was not the first to ask this question. In fact, not too long ago, I guess September 3rd, right before the break, Max Payne asked this question: is it possible to install Flux in a cluster without a CNI? Say using host network true. And the question is an important one because effectively what's going to happen here is that we could give the Flux controller, the thing that's actually going to do the instantiation, the ability to operate, and also give it host network so that it could do its work before Cilium is installed. And in fact, in this particular example, Max is trying to do exactly that. He says, I need Cilium to be initially installed and updated in the future by Flux from Helm release manifests in the Git repository using GitOps. Stefan is a friend I've known in the Kubernetes community, also just an incredible person. And he's got one of those minds that once somebody asks an interesting question, he totally can't let it go. Like he is one of those great minds that just kind of digs right into it. Really enjoy my time with Stefan. He's a great guy. So they get into it a little bit. And Stefan says, well, if you were going to do such a thing, then one of the things you'd need to do is Flux needs a CNI to be able to access the source controller service. And you can install a CNI plugin at Cluster Bootstrap with the Helm CLI, and then Flux will take over the release if you define a Helm release with the same values. The problem, Max says, is that I have two places where the Cilium Helm values exist. I want to do the initial installation of Cilium from the Helm release file. Can I achieve this using some job with the Flux CLI? We have a lot of clusters, and I need to install everything declaratively. And he's using Talos, which is great, and it can install Kubernetes manifests at Bootstrap time. So I wanted to use Flux CD first, and then it should fetch everything from the Git repo, which is kind of like our goal. We're basically going to try and do exactly the same thing. So it might be kind of fun to see what actually happened here. So they get into it a little bit more, and Max puts a link up to a repository that he created called Flux Without a CNI, in which he describes a customization on the Flux install YAML. So like if you were to do Flux install against a cluster, it generates a big old YAML file that looks exactly like this one. And his customization, what things he had to make, what things he had to change to be able to allow Flux to run without a CNI deployed so that it could then apply the manifests from the target cluster. So pretty cool stuff. Not too many changes. Made a few changes here in the customization. But let's go ahead and see what we got. Let's play with it a little bit. See what we can find out. So what we're going to do next here. So that's one thing. And before I get into trying this out, which I'm probably going to do against a guest cluster, just give it a shot, see what happens. Stand on the shoulders of giants, they say. The other thing I found when looking into this was, as I said, Stefan's brain can't let things like this go. He has to kind of explore them and figure out what is interesting about them. He decided to use QLang to explore this. Started a new project called Flux AIO all in one. It is an experimental distribution made with Qlang for running Flux on Kubernetes clusters without a CNI plugin being installed in advance. The main difference to the upstream distribution is that Flux AIO bundles all of the controllers into a single Kubernetes deployment. The communication between controllers happens on the loopback interface. Hence, Flux can function on clusters that don't have a CNI plugin installed. This allows Kubernetes operators to set up their cluster networking using it in a GitOps way, which is super interesting. So basically what he did, he made a distribution of Flux that has all of the components in the same pod, running as different elements in the same pod so that it could actually interact between all of the different things. And in that way, we could deploy that all in one piece. It can pull down the manifests that we care about inside of a Git repository, apply them to the cluster, and then at that point, because Flux is doing all of the work, we could actually just upgrade. We could install a real Flux on top of it, make it self-managed, and then remove this Flux AIO from the set if we wanted to. Or that's the way I understand the plan so far, which I think is super, super interesting. So we have two different ways forward here. I was expecting to find, at least one interesting way forward and to start exploring it with you. But in this particular case, we have two different ways forward. And I think I'm kind of tempted to take Stefan's way to see how it would work. But I'm also kind of tempted by what Max has here. So I will leave it up to the audience. If you're listening out there, what do you think I should do? Do you think we should try Stefan's way, the Flux AIO, or do you think we should try Max Payne's way, which is basically kind of a similar approach, but slightly different implementation? First answer wins. If you've already typed in your answer, then you're probably going to be the one that gives me the answer. Throw it in the chat, and we will go for it. So Flux-AIO or Max Payne's way. What do y'all think? I like Stefan. Stefan is pretty great. It's pretty easy to like Stefan because he's pretty awesome. All right, there's our answer. Michael Forrest says, I like Stefan. So we're going to go with that. All right, so let's go ahead and try this out. Boop. Let's pop over here. See? Oh, that's where it is. Okay, copy quick start .yaml. I see what happened. All right. So that gets me everything I need to basically get started here. What I want to do is I want to check out that new repository. So I'm going to do git clone, and then we'll grab the URL. I'm probably not going to make any changes to it right away. Thing there. we need kubectl. Need kind. Customize. Oh, I don't have customize. And then we need Flux. We don't have either, so let's go get both of those. Curl bash. Bum, bum, bum. We have Clusterized now. Now we just need to have Flux. So let's go ahead and grab Flux. Flux AIO. That's a surprise. Flux. GD.io. Go. Releases. Copy link address. That. Right. We have all of our dependencies. Oh, do we have Q? We don't. Oh. Okay. Find Q. Oh, I think I meant to hide that. Sorry about that. Okay. Getting started. Oh. Official Q releases. That's a beta. I don't want a beta. I want something stable. That's me. Let's see. Releases. Tags. 043. Copy. Right. Okay, so we have everything we need for this Flux AIO business. Make There's a few things. Let's take a look at the make file. So we've already done the install part. We don't need to do that part. Ah, that's the install part, Q install. And then there's an uninstall of Flux. Configure Flux automatically to upgrade itself. Format and vet all the Q definitions. Qgen. Importing the Kubernetes extension set. Importing the CRDs from Flux. This must be part of how it actually gets built, because it looks like Q install is the install part. And then there's Flux autosync. Okay. Now, make install. Server can identify and respect requested resource, task field, Q applied. Oh, okay. So we actually need a cluster to do this on. So what I would like to see is this. Because I want to do this as a, I see, okay. Script-ir. So what I want to do here is I want to actually produce the set of manifests that would be used to generate this. And I can see that in this output, in this make install command, it's expecting just to drop this into like a kind cluster and run it that way. And what I want to do is I want to see the actual manifests that's there. So what I'm going to do is I'm going to change this command, cube apply server side -f- to like cube, I don't know, apply -- dry run. And then we'll take a look at the output, see what that looks like. To do that, though, I need to find where it's being run. So it looks like oh, nice. Okay, so there's a couple of different commands here. There's an install, which will do the install against a target cluster. And then after that, it will sit and wait for that to complete the installation. Then we have publish. Oh, look at that. Build file create dist aio.yaml. After build, flux push artifact. Then automate, which is an apply. Those are the resources and the custom definitions. I think what that should do, create this. And that, I believe, is probably everything that we need to get started here, which is the entire set of manifests all in one YAML. Generated with QLang. Pretty cool. So QLang is basically a way of, I mean, it's a very powerful language. It can do lots of really interesting things. And in this particular context, what's happening is it's being used to generate a set of manifests that reconfigure the set of manifests that Flux install.config would use into this model. So it's actually very, very similar to what, hey, Ahmed, good to see you. It's very, very similar to what we saw Max Payne doing, where he was making that adjustment. In fact, you know what might be interesting is this. Let's go ahead and grab the install config. Have a find install Flux help Flux install try run export. Okay, so let's do that. It's a bunch of header stuff that is different between the two, which is fine. But then we have some spacing differences. No big deal there. They're both not in the same order, that's for sure. Wow, that's interesting. That's not there. Or actually, that is there on the AIO version. It's cluster admin. A smaller set of the CRDs is being applied. It's not, doesn't have all of the descriptions and stuff. Much more abbreviated version. So if you're going to use kubectl explain or anything else like that, you'd want this one on the left, not the one on the right. But that's fine. That's fine. We don't have to worry about that too much. Basically just putting enough scaffolding in to get everything started up. These are all the custom resource definitions that would be applied. Blah, blah, blah. There we go. What's that? Again, no. More CRDs. More CRDs, so many CRDs. Which makes sense. I mean, there's a lot to configure in Flux, and the CRDs are basically the way through by which you configure all of these components. This is a custom resource definition as well. Let's look for a deployment, because I think that's where we're going to see the more interesting differences. Over here, but we don't see it. How about we do this? Vim install YAML. There's our notification controller, source controller, home controller, customized controller, all the different controllers. And these are all different deployments. And if I look at the AIO, I should see only one deployment with everything in it. Here, it's above. So deployment got put at the bottom of the document. We have our runtime controller. We have our helm controller. We have our source controller. All of these components in the same deployment. And that's the difference between the AIO piece and the other one. The other difference is this role annotation, app Kubernetes IO role cluster admin, which is super interesting because we're giving Flux a cluster admin permission. I'm curious, like in the regular Flux, if that's also true. I mean, it would make sense. It is true, yeah. It does make sense. All right, so what we've got so far is we found the AIO piece, we generated the manifests, we are now ready to proceed from here and see if we can get a cluster resource set to do the installation of the AIO.yaml. Before we get started on that, though, I'm going to step away from the camera for just 1 second and grab some water, and I'll be right back. All right. Water acquired. Let's see what we can do here. Now, when we spoke last time, what I did before to generate these manifests, let's take a look at that real quick. I think I put it under Cilium CLI. This was the deployment of the Cilium CLI. This is a manifest that I applied. Here's the cluster resource set that I applied. And I created that config map, Cilium CRS CM. And the values, the content of that CM, of that config map was this content. So let's go ahead and instantiate our situation here and see if we can get things to a place where we can try this out, see what happens. So like we did last time, I'm just going to do a kind create cluster config kind mn. This is going to be our management. This is going to be our management cluster. You know what I remember? I remember there being a thing where when I do the installation, to enable it, I have to have cluster resource set, That's already in there, I guess. I thought maybe there was a thing that I had to have to get this to work. Quick start. For cluster topology, true. Okay. Yeah, I think that's what I wanted to do. All right. Back over here. Get nodes. Get pause-a. You can see that we have a Kubernetes cluster with no CNI installed. So let's do our Cilium install. That will get us a CNI on the management cluster. And then we will proceed from there to do our cluster kettle init. Now, like we did last time, I'm actually going to be exploring this with KubeVirt and with Kind. So we're going to be initting both. This is our install. So we've already done our Cilium install. The next piece we're going to do is we're going to apply kubevip, and then we're going to install KubeVirt, and then we're going to and then we're going to get everything like that going. We're going to export cluster topology equals true, and then we're going to do our init. So let's go ahead and do that piece of it. And that will have instantiated our management cluster. All of that I've just done there, I'd love to do that like post Flux install, right? So it'd be like kind create, Flux init, do all of that stuff, including the CNI installation of that management cluster. And then from there, create guest clusters and then do interesting things with those guest clusters, like, cluster mesh and all of those sorts of things. But we'll get there. It's going to be a bit of a journey, but it will happen. So we're still installing our KubeVirt stuff. And once our KubeVirt stuff is installed, then we will be able to do the cluster kettle init. Lots of exciting things coming up toward the end of the month, or actually the beginning, I guess, of next month. I'm going to be hosting a meetup down in the South Bay. If you'd like to know more about it, you can follow us on Twitter and see more information about it. So I guess while we're waiting for this to kick off, I'll go ahead and bring that up. We just started announcing it earlier. There we go. So this is the link to the meetup. If you want to come check it out on February 9th in Mountain View, definitely come by. I'll be presenting, and I'm looking for possibly one other presenter to come join me and talk about all exciting things inside of Cilium and what's happening in the eBPF space. So definitely come check it out. There we go. We're handling our cluster kettle init now. And there we go. We have our cluster created. So now if I do kubekettle get pods-aw, you can see everything is running, including, I think, Yeah, it should be everything in place. Okay. So the command I used to create the config map from before. So I'm going to do something very similar there. Let's see, where did I put that? I put that inside of Flux AIO. Just Kernel create config map Flux CRS-CM file equals. We'll put that in the default namespace. It'll get config map cat describe. There we go. Bunch of data. That is the CRS we want to apply. Okay. Control D, clear. And we're going to take a look at the Cilium CLI CRS Cilium. This is the cluster resource set that applies that config map. We're going to create something very similar for the Flux one. So let's just copy this. Just okay, and this is assuming, I think we have to actually, I wonder if cluster selector is cross namespace. Is cluster resource, so let's do this. I really don't know. Kernel explain cluster. So that's the resource set, but is it a global or is it local? So kubectl get API nope. Cluster resource sets. There's a cluster class. So I'm pulling up this document because I want to understand whether the tooling is namespaced or not namespaced. So if I say namespace equals, it will show me all the things that are namespaced, and then I can do a search for resource set bindings and cluster resource sets are both namespaced, which means that I have to have the clusters that I'm addressing be in the same namespace, be defined in the same namespace as the config map that I want to apply to them. Okay. That's interesting. All right, so let's keep going. All right, so we've created our config map. Let's go ahead and just create like a simple cluster. convert copy. So that's my quick start. I believe this all gets thrown into the default namespace. Yeah, see, namespace default. So we're just going to create this one, which is a pretty bog standard VirtIO or KubeVirt based cluster. And since we already have KubeVirt installed, that should happen pretty quickly. So let's go ahead and do kubectl apply-f copy quick start. We've got machines -AW. Now this is going to use KubeVirt, which is going to interact with the QEMU, the KVM QEMU system on my underlying host here, and it's going to create some virtual machines for us that have all of the things that a KubeVirt cluster would create. So let's go ahead and get that installed, and once that's up, we'll play a little bit more with the AIO stuff and see if we can get that to apply to our guest cluster. And if we can do that, the next step is going to be configuring Flux AIO to point at a set of resources that will apply to this cluster. And then we'll try that out. But so far, things are progressing pretty well. We've been at it for about an hour. We're making pretty good progress. We've done a lot of discovery. Lots of good stuff happening. I think if I get Flux installed, I'm going to stop there. Yeah. Thank you, Michael. Michael is as enthusiastic as I am. Thank you very much. Waiting for these VMs to get kicked off. Hopefully pretty soon I'll get the control plane going. And then we can move from that into the next step here. If I forgot anything, seems like it should be working. Let's just go ahead and break this watch, and we'll do PS. We do see the VM started. I see provisioning. You can describe machine. Quick start control plane. I'll get events. Pulling the image down probably took a minute. That's fine. That's the operating system for that VM. And then it started it. That's true. Successful set node ref. That's a good sign. I think that means that we are up on that node. Yeah. So we got the one node. Now we're waiting for the other one to apply. While we're waiting for that to finish up, so let's go ahead and jump back into Flux AIO dist and take a look at CRS Flux. Change some things around here. I'm going to call this Flux CRS. Put it back in the default namespace for now. Flux true. Okay, so this cluster resource set will be the creation. And when I apply this, then it should match all clusters that have flux true, labeled or that are labeled flux equals true, and then it should try to apply that set of manifests to them. So the kubectl get clusters. See the CAPI quick start is provisioned, and if I do kubectl get machines, I see both machines running. And then, you know what, I'm just going to grab the kube config here for this. Before I do that, I'm just going to go ahead and apply that because it's not going to match anything at the moment. So apply -f CRS flux. Conversion webhook cannot unmarshal mesh label of type string. Oh, I messed up. Can only be set. Oh, look at that. If the cluster resource set feature flag is enabled. I thought I had looked at that. Oh my goodness. I remember how I did this last time. And cap B system. Then under feature flags, cluster resource set true. All right, there we go. kubectl, rollout, restart. That should actually happen automatically. And then what I'm going to do is actually fix this. What was that? It's a resource set flag. Feature get name, cluster resource set, variable name to enable, disable the feature get, X cluster resource set. So then we can go back over here. So now if I do that apply again, oh, all right. kubectl CRS. Okay. Resource set. So there's our Flux CRS. We have that there. Show YAML. It's going to match on any clusters that have a associated label. CI Flux. Kernel get clusters. Kernel label cluster. Quick start. CI equals Flux. Pause dash A. So now at this point, we should see that applying to the namespace or to that cluster. So next thing we want to do is we want to do cluster kernel config. No. Get kubeconfig. Start. Kubeconfig equals copy kubeconfig. So get nodes. So there's our cluster. Check it out. All right. It's depending, which I think means that it's likely complaining about the fact that scribe deployment dash and Flux system. It says pending. Pending probably means that it's not supporting the, what do you call it? I'll describe replica set. System. Flux will create. It'll describe pod flux. And flux system. Scheduler, 2 nodes are available. One node had node role master. That the pod didn't tolerate. One node had taint not ready, which the pod did not tolerate. So what's happening here is that in this model, because there's no CNI, we have to make it so that the deployment understands that it needs to tolerate everything. It needs to just tolerate everything. So we're gonna do that. Tolerations, because it doesn't. Oh, look at that. No execute. There is a toleration for node Kubernetes IO not ready. Deployment and system. Okay. So yeah, that is a problem. There's no tolerations. So what we're going to do next is we're going to go ahead and add one. So we would do kubectl explain pod.spec.tolerations. Is that right? Yeah. Right underneath the spec. Tolerations. Operator exists. It's kind of a Borgism. And what this does is it makes it so that it will tolerate anything. Doesn't matter what it is. It's just, it defeats all of the taints and toleration game completely. It basically means that doesn't matter what, we're going to support it. As long as there is if there is something to tolerate, I will tolerate it effectively. Key expected array. Away we so the last thing that needs to be added to that AIO thing is the ability to support tolerations. And then we're off to the races, I think. This is actually also interesting because I don't know if the images that Stefan put up are publicly available or if they're behind an authentication wall. So because maybe they can't get the images. We're going to have to see. Pulling the images down. Flux. Wait. Did not make hostnet true? Without hostnet, the pod can't come up either. So even though it might tolerate everything, yeah. Make one more change. Kernel explain pod.spec.host network. Host network. True. Ooh, all right. So now we have a working Flux. So we had to make two changes. We had to make host network true. We had to make host network true, and we also had to make it so that it tolerated everything. And that means that now it can apply anywhere. So kubectl pod-and flux system-oy. It put itself on one of the worker nodes. It's got an IP of 10.244.123, and we got it working. So that's kind of exciting. And I think what we're going to do is we're going to stop here, and when we come back next time, We're going to get the whole Git repository working with Cilium's Helm chart, and then we're going to use this mechanism to handle the installation of the Cilium Helm chart, and also make it so that Flux will auto upgrade itself. And then away we'll go. All right. Well, thank you for coming on this journey with me. It's been really interesting. I hope that you found it interesting, and I hope that if you're in the Bay Area or and you want to come check out the meetups, definitely come check it out. I look forward to seeing you, and I hope you have a great week and a great weekend. Thank you. All right. Where is the... There we go. Bye, all.